Welcome back, chemistry students. The objective of this lesson is to determine how the rules of significant figures are used in rounding. And we're talking specifically, so we're going to do just some quick rounding problems. And this will lead into when we do calculations, how do we know how to round? And just it's a little bit, the rules are a little bit different when we talk about addition, subtraction versus multiplication and division. So we'll address that. But first, let's just practice rounding some numbers. All right, so rounding, the rules of rounding. You've done this before, you've done this in math. So hopefully these are the same rules that you've used in other aspects of your high school career. So the rules of rounding, if the digit to be eliminated is less than 5, we just drop it. So the first example, 157.52, if I tell you that we've done some calculations, you need to round this to 4 significant figures. So that would be the 1575. So we're just going to get rid of the 2. And since it's less than 5, we literally can just drop it. Deciding blue is probably not the best color to use here. So 157.5, the 2 is going to go away, no one's going to miss it, basically. So let's look at, and it says if the digit to be eliminated is 5 or greater, then the number preceding it must be rounded up. Okay, so we'll look at a couple more examples. So if I have the number 201, and I need to round this to 1 significant figure, we simply can, we're going to get rid of the 1 and the 0, and since they're less than 5, you will notice I did not write just straight up number 2, okay? Because although the number 2 is 1 significant figure, it's very, very different in value than 201. So 201, we simply round it to 200 if we need 1 significant figure. Remember those rules of determining significant figures that we talked about in the last video? These zeros are not significant, okay? So 200 is how we would write this 1 significant figure. Do not just write the number 2. That is not correct. It's not even close. So let's be very careful about that. The next number, 12555, I have to round this to 3 significant figures. So I need to get rid of the last 2 5s. Since these are 5 or greater, I'm going to round this to 126, but then I need zeros for placeholders. I don't just write 126. That is not the same in value, not even close in value. So you have to make sure you have those. This is where the zeros as placeholders come in. Let's do a couple more examples really quickly. All right, so let's do just a couple more examples. Pause this and try to work through these on your own. I'm just going to zip through them really quickly. So if I have 895.50, I need 3 significant figures. That means these 2 digits are going to go away. This is a 5, so it's going to bump this number up, and then the decimal goes away. So it becomes 896. 957.02, we really just want the 2 to go away. We want 4 significant figures. Remember that zeros at the end after a decimal are significant, so that would give us 4 significant figures. Like so. So make sure you're reviewing those rules from the previous video as well. All right, the reason this becomes important is because when you are performing calculations or adding data together, those kinds of things, your answer cannot be more precise than your weakest data point. Okay. So, and there's, you know, again, it's a little, the rules are a little bit different with addition, subtraction, and with multiplication, division. So this example right here, if I'm finding the area of a room, so I'm multiplying 7.7 meters by 5.4 meters, and I carry this answer down, my rule in multiplication and division and addition and subtraction says my answer cannot be more accurate than my data. And here we have a problem, because we see that we have, this is carried to 2 decimal places, it's 4 significant figures. This needs to be adjusted to reflect the data that you're working. I'm going to talk about this rule in a minute, but this actually, my answer can only be 2 significant figures. So I have to round this to 42 because I have to get rid of the 5 and the 8. The 5 is going to bump this up to a 42, so that gives me 2 significant figures. So here are the rules. In rounding, in addition and subtraction problems, the answer must be rounded to the same number of decimal places as the number with the least number of decimal places. So when we're talking about addition and subtraction, we're talking about places. So we're talking about like this is in the ones place, this is the tenths, hundredths, thousandths place, and this number we have in the ones and then the tenths place. So my answer cannot be more accurate than my least precise piece of data. This is my weakest link right here. Okay, I have 1 place beyond the decimal. So if I calculate this and get this answer, I have to round this to 1 place beyond the decimal. To do this, I think a little bit trickier. Let me 15.979. So I can have more than 2 digits, but I can only be accurate to my tenths place here. So I actually have to bump the 5 in 15 up. But then I need to include a 0 to make this accurate to the tenths place. So this would be the correct way to express this number. I did another example. I think this is actually from one of your worksheets. Another example here. So this is addition. We have 2 decimal places, 2 decimal places. We add this up, but this is not in it. We have 2 decimal places. However, this is not in correct scientific notation, so I need to convert this to 1.127. Remember, I just made this number smaller just by 1 decimal place. I have to make this number larger by 1 decimal place. Now, all of a sudden, my answer becomes more precise than my data, which are carried to the hundredths place. So I got to get rid of the 7. If I get rid of the 7, I need to bump the 2 up. To 1.13. So now this is the correct number of significant figures. Again, we're talking about places. Multiplication and division, again, a little bit different. The rule is a little bit different, and I did an example here. So when we talk about rounding in multiplication and division, the answer must be rounded to have the same total number of significant figures. Now I don't care about places at all anymore. I want the total number of significant figures as the number that is my least precise number. So in this one, this top number, 3 significant figures, this is obviously one significant figure. So because one significant figure is the least, precise data, my number, so I multiply these, I get 6.66. I have to round this to one significant figure. So my 6, because I'm getting rid of a 6 in the tenths place, I got to round that 6 up to a 7, so that it is one significant figure. So this is my final answer for this one. So multiplication and division, it's all about total numbers of significant figures. So now we went over how to round numbers, and we went over how to apply those significant figures to rounding in the final answers for both addition and subtraction, which are the same as each other, and then multiplication and division, which are the same as each other. Rounding for addition and subtraction, we care about places, whether it's in the tens, ones, hundreds, or tenths, hundredths, or thousandths. But you're always looking at that least accurate piece of data. Multiplication and division, total number of significant figures. Again, looking at what the significant figures are for that weakest piece of data. So hopefully that makes sense. You're going to get lots of practice, I think, so you'll get really good at this.